Hello, my beautiful AP Computer Science students. Welcome to another lesson where I, Goldie, am going to take you through some exciting Computer Science A information. Today we're going to start Unit 9, Inheritance, and in our very first lesson we get to go over superclasses and subclasses, which if you're just starting this unit, you have no idea what those things are, but that's why I'm here. Okay, so inheritance starting unit 9 now. We are going to go over exactly what inheritance is, and I'm going to kind of build a basic inheritance hierarchy and what that looks like in code. We're going to expand on the properties of inheritance and all of the good things that inheritance allows us to do in the upcoming lessons. So today is just an introduction into it, what it is, and a little bit why it's useful. So inheritance in Java allows us to build classes from other classes, and specifically classes that are related in some way, as you're going to see. It's a very powerful tool in object-oriented programming, and it just lets us work with objects in kind of an expected way, like we would in real life. Okay, so in order to get an idea of what inheritance exactly does for us, we're going to look at a hierarchy of a polygon. Okay, so being the geometry teacher that I am, I could not resist writing a program that involved shapes. Okay, so take a look at this hierarchy. We're going to point out some important features of this hierarchy in a few minutes, but hopefully this isn't shocking to you. You've had geometry before. You can see at the top we have a polygon, and a polygon has a very specific definition with a very specific property. Okay, a polygon is an enclosed shape using line segments. Okay, so anything can be classified as a polygon as long as it follows that specific definition, right? An enclosed shape using line segments. Two examples of polygons from there, a triangle and a quadrilateral, right? A triangle is a polygon. A quadrilateral is a polygon. But in addition to being polygons, each of those shapes adds its own specific properties, right? A triangle is a three-sided polygon versus a quadrilateral, it's a four-sided polygon. So both of them are polygons, and that's why you see those line segments, those arrows pointing back to polygons, because a quadrilateral is a polygon. A triangle is a polygon, but they're more specific objects of our polygon object. And we can break it down even more for there. So I'm going to break down the quadrilateral here. So you can see that there's three types, well, more, but there's three types that I define here of a quadrilateral. I have a kite, a trapezoid, and a parallelogram. And again, all three of these are quadrilaterals. Okay? All three of them are polygons, right? A parallelogram is a polygon, but they have specific properties. So a kite, trapezoid, and parallelogram, all three of those shapes have four sides, right? But they add their own property. Like a kite has no set of parallel sides, a trapezoid has one set of parallel sides, and a parallelogram has two sets of parallel sides. Okay, so all three of them are quadrilaterals, all three of them are polygons, but they add their own unique properties. Okay, and then you can see I break it down one more time. I have a specific type of trapezoid. An isosceles trapezoid is a trapezoid, but again, it adds its own property. Same thing with a rectangle or a rhombus. A rectangle has four right angles, a rhombus has all sides congruent. Both of these are a parallelogram, and they have those properties, but they add their own properties. And this idea of building objects, building these shape objects, is what inheritance is all about. And it's beautiful when I can involve other branches of mathematics. Geeking out, right? So let's go back. What I said, a triangle is a polygon. So it has the properties of a polygon, plus it adds its own that are unique to a triangle. Okay, so a triangle is a polygon. So it's going to get all of polygon's properties plus add its own. Same thing with a quadrilateral. A quadrilateral is a polygon. So it gets all the properties of that polygon and then it adds its own. And then from there, each descendant of that quadrilateral inherits attributes from quadrilateral as well as polygon and adds new attributes of its own. So like, for example, our parallelogram, right? Our parallelogram has two sets of parallel sides. It also has all of the properties of a quadrilateral, and then it also has all of the properties of a polygon, right? Because a parallelogram is an enclosed shape using line segments. A parallelogram does have four sides, right? And then it adds its own properties. So in Java, a class, let's say like quadrilateral, that inherits behaviors and attributes from another class creates an inheritance hierarchy. Okay. This is inheritance, right? Where an object inherits attributes. In this case, we're just talking about attributes, but a class can also inherit behaviors as well. So polygon represents what we call the superclass, and the quadrilateral represents the subclass. Okay. Subclass and superclass. So this is our super, and we would call this our sub as an example, right? Just looking at the relationship between these two, polygons are superclass. It's also called a parent class or a base class. And then quadrilateral would be the subclass, or it's also called a child or derived class. But we'll use superclass and subclass because those are the two used on the AP CSA exam. So we'll stick with those two words, super and sub. Okay. Now that's not the only super-sub relationship. That's just an example of an inherited relationship there. Quadrilateral is also a subclass. So it's a subclass to polygon, but it's also a superclass to kite, trapezoid, and parallelogram. Okay? So quadrilateral here, it's a subclass to polygon, like we just said, but quadrilateral is also the superclass to kite, trapezoid, and parallelogram. Okay. It comes back to this hierarchy. So when you make this hierarchy and you have your arrows branching off, it creates that subclass, superclass inheritance. Okay. Trapezoid here, okay, trapezoid is a subclass to quadrilateral. So quadrilateral is trapezoid super, and trapezoid would be the sub. Or we could say trapezoid is our super, and isosceles is the sub. Okay, all right. So it's all about where it falls in the hierarchy. Okay, sometimes it's the super, sometimes it's the sub. The superclass subclass relationship happens between two classes. Okay, so isosceles and trapezoid, isosceles, trapezoid, and trapezoid. Trapezoid's the sub, isosceles is the, or excuse me, trapezoid is the super, isosceles is the sub. Okay. So when we talk about super sub, it's between two classes in our hierarchy. Okay. Or like kite and quadrilateral. Okay. Kite is a subclass to quadrilateral, who's the superclass. Okay. Kite doesn't have any derivatives off of it. It's not a superclass at all. Kite is only a subclass because nothing else comes off of kite in this example. Okay. Superclasses and subclasses in this relationship. We have also started talking about a special type of relationship called an is-a relationship. Okay. An is-a relationship. The subclass and the superclass form, it should be N, is a relationship. Okay. So when we're looking at a hierarchy like this, okay, X is my subclass, Y is my super. And I say X is a y. Okay? Meaning that x is a y, but it also adds some of its own unique properties. Okay? So if you look back at our shape inheritance, a rhombus is a parallelogram, a rhombus is a quadrilateral, and a rhombus is a polygon. Okay? All the way up through that relationship. Let me go back. Right? I wrote on all sides. So a rhombus is a parallelogram, a rhombus is a quadrilateral, and a rhombus is a polygon. Right? A rhombus has all of these properties and it adds its own. Okay? That's the is a relationship. And it's an important one in inheritance. We've talked about a has a relationship before. Okay? Back in Unit 5 is when we introduced it, and then we've just been working with it since. Or Unit 2 is when we introduced it, and we've been working with it ever since. A has a relationship is represented by instance variables, right? A parallelogram has a set of parallel sides. A rhombus has a set of 4 congruent sides. Okay? A has a relationship is the qualities that they possess. An is a relationship is the qualities it inherits from the hierarchy. Okay. So that is a relationship and the has a relationship, both of those are very important distinctions in this course. So make sure you know. And why are they important? Well, when we're talking about creating objects in our program that represent objects and ideas in the real world, we have to make sure we get those relationships correct. Right? If we don't get those relationships correct in our program, then it's just not going to make sense to model what we're trying to model in the real world. Okay? We want those relationships to be representative of what we're trying to create, right? So what's up with inheritance, okay? In an inherited relationship, why do I care about that inheritance? Well, the subclass will inherit all of the superclasses, instance variables, and methods. Okay? That's the big idea of inheritance. Right? All of the instance variables and methods in that is a relationship end up getting inherited by the child class, by the subclass. Okay? Plus, they add some of their own. Okay? Are you ready for this? Let's look at some code. Okay. I'm not going to do the shape example quite yet. We work more with shapes in the homework and the programming assignments that I have. But I'm actually going to create a new example, and we're going to work with this example throughout our notes, throughout the next couple of lessons here. So if I look over here, I have my class. It's called person. Okay, so person is my object. I have a person. Every person has an age. So I have an instance variable called my age. I have a constructor person that sets my age equal to 0. I have a setter and a getter. I have a method called have birthday, and I have a method called say something where it says I am a person. Okay. So look over that code, make sure that looks good, right? That's like any class we have ever had. Okay, basic, straightforward. Now I'm going to create another class, and I'm going to have it inherit from person. Okay. Now you're about to take a look at the code of inheritance. Are you ready? That's it. Okay. That's it. I'm going to talk about this keyword extends here in a moment, but it's called public class student. Now a student has my grade. My grade represents their grade level. So in my default constructor for a student, my grade equals 9 means a freshman, 9th grade, right? I have a set grade and a get grade. I have something called pass exams where my grade increases by 1, and then I have something called say something. Okay. Now I say this is an inheritance example because of this keyword extends. That is the only word you need to invoke inheritance. Isn't that cool? If we took off, and I'm covering it up on the screen, but you can't see that. If we took off that word extends person, we would be left with just a regular class we could have created on our own, okay, which is pretty neat. That extends person is the only thing you need to invoke inheritance. Okay. Now, extends is the key word, but what it represents is the is a relationship, because student is a person, right? If you think of a student is a person, right? A person who the student has an age, so it inherits that age from person as an instance variable, and then it also is going to inherit all of the methods, okay? All with that single keyword, is a, or extends, which represents is a. Now, notice the opposite isn't true. A person is not necessarily a student, right? Like me, I am a person, but I am not a student. The relationship does not work both ways. It is a one-way relationship. Student is a person, but a person isn't necessarily a student. So a student is a person. Student, any student object, will inherit all of person's instance variables and be able to run any of person's public methods. Isn't that cool? So any student you create is going to have a myAge property as well as a myGrade property. Okay? And then any student is able to run these public methods. Okay? It does not run the constructor. Constructors do something a little bit different in inheritance, and we're going to talk about that in lesson 2. Okay? But the instance variables and all of those public methods, a student is able to run and have. Run and have. And again, it's a one-way relationship. So student gets all of this stuff from person, but not vice versa. Person does not get anything from student. Okay? Person is just a person. The is a relationship is one way. Student is a person. Not going the other way. Okay, let's add on to this. I have one more class. I have an AP student. Okay? AP student extends student. So that's inheritance. Okay? And again, that's a one-way relationship, because if you're an AP student, you are a student, right? AP student is a student, but not the other way around. A student might not necessarily be an AP student. Okay? So here's AP student. They have one instance variable. They have a constructor. And then they have these public methods. And a hierarchy of this relationship, when you're working with inheritance, a lot of the times a hierarchy is a good way to visualize the relationship that's happening. This is what we're looking at. We have person at the top, student, AP student. So think of the top as kind of your general object, and you get more specific as you move down the hierarchy. Okay, it was the same thing with our shapes, right? At the top it was polygon, and then we got more specific in the type of shapes as we move down. So same thing here. Start with person, student got more specific of a person, and AP student is a specific type of student. Person does not inherit from anything. So a person only has the properties that they have defined in their class, which is myAge. Student extends person. So a student is going to have all of person's instance variables, which in this case is just myAge, plus person adds their own. They add myGrade. Okay? So a student actually has two properties. Even though in the class itself you only saw myGrade, the fact that it extends person means that it also gets the properties from person, okay, automatically because of the word extends. AP student extends student. So AP student actually, so they added their own my AP exam score. You can see that right here. And because they extended student, they got student's properties. And what were student's properties? Well, student's properties were myGrade, that was defined in student, but myAge as well. okay, because that was defined in person. So in a hierarchy, the is-a relationships extend all the way back up. Okay, you follow those arrows all the way back up. AP student, is a person. Okay, and that's the basics of superclasses and subclasses. Okay, now I know you're left with a lot of questions. Okay, that's on purpose to leave you wanting more, right? But remember, this was an introduction into the inheritance hierarchy. Exactly what it is, what it does for us, and then just to give you a little example of what it looks like in the code. And you can see what it looks like in the code is pretty straightforward. To have inheritance, all you need is the extends. It's very neat. So in lesson 2, that's where we're going to be talking about methods and constructors for those subclasses. Okay, thank you guys so much for watching, and I will see you next time.